Okay, so we're entering into polar coordinates. So usually we use Cartesian coordinates, right? So this point here is this distance x, this distance y, and that's how we get that xy point, right? So now we're going to use a different coordinate system introduced by Newton called the polar coordinates. Okay, so the polar axis, there's just one. So there's just one polar axis. It starts here at like you would call 0 and goes out this way. So that's it. So you can kind of superimpose an x-axis right there, right? So you can see, oh, x-axis would be here and y-axis would be here, right? Okay, so a point on the in the polar coordinates would be out here, and this would be a distance r from the origin, so that would be a distance r, and theta would be the angle moving up from this polar axis. So if the angle is positive, you move counterclockwise, like you usually do, positive angle. If the angle is negative, you move counterclockwise, so you would move down. And r is always the distance. Okay, so points are not unique in polar coordinates, but let's plot a couple of these points. So again, it's just the polar axis. So we go an angle of 5 pi over 4, which takes us all the way over here, right? And then a distance out of 1. And so this would be the point 1 5 pi over 4. Okay, so this point here, go an angle of 3 pi. Again, it's just the polar axis, right? So there would be 1 pi to here, right? 2 pi to here, 3 pi gets me back over here, and then I go out a distance of 2, so 1, 2, so there would be the point there. So it's way out here. So again, if I was to superimpose an xy axis, because that kind of helps, that would be at the point -2, right? Okay, so let's look at this. So this one has a negative angle, correct? So again, it's just the polar axis. So I go -2 pi over 3. So that would be all the way over here, right? And go out a distance of 2. So out a distance of 2. So 1, 2. So this would be the point. Okay, so I haven't done a negative r yet, so let's do that. So here I have an angle of 3 pi over 4, so that gets me to all the way over here, right? And then go a distance of -3. So what that means is I move the opposite direction. So here's the origin, so I'm going to go 1, 2, 3. So this point here, down here. Okay, so the negative means the opposite direction. Okay, so there is a connection between the xy, right? Xy, Cartesian coordinates, and the polar coordinates, right? So let's look at this for a second. So isn't this the same as saying x over r is cosine of theta? So if I have this polar coordinate here, right, r theta, I know that this distance here is r, and this distance here would be theta, and I know that this point here would be called xy, correct? So this would be the distance y, and this would be the distance x. So because you know your unit circle, you know that cosine of theta would be adjacent over hypotenuse, x over r. And the same thing for this one here. So y over r would equal sine of theta. So you know sine of theta is opposite y over hypotenuse. Okay, so now we know that these are the conversion factors between the Cartesian and the polar. This gives us that tangent of theta is y over x, and then we know the unit circle, right? R squared is equal to x squared plus y squared. Okay, so we're going to be doing calculus with these polar graphs, and so we're going to need a graph, like a y equal f of theta, like we usually have a y equal f of x, or we're going to be thinking of theta as a parameter, just like we did in t-land, right? X of t, y of t. So let's just get a couple of these graphs down so we can see what we're looking at, because it's going to be helpful for you. And then we'll move into finding slope. So you can use your calculator, and I'll do a video to follow of how to use Desmos as well to get graphs. But it's good for you to be able to just know basic shapes, just like you know a basic shape of a parabola or a line. So these two here, they have a special quality that it just takes 0 to pi to go around. So if it's cosine, it's always going to be symmetric with the x-axis. So I'm always going to draw the xy axis so I can see what it is. So if I have r equals 3 cosine of theta, And I'm just going to plug in a few points just so you see. So if I plug in some thetas, what the r's are equal to. So if I plug in theta is 0, you know, whoops, that is an r, not an s, r. There we go. I get cosine of 0, which is 1, so I get 3. So then let's just go to like a pi over 2. So cosine of pi over 2 I know is 0. And then cosine of pi gives me a negative 3. Well, that's not too many points, is it? So let's just go to one more point in between the 0 and pi over 2 to get a pi over 4. So I'd get a 3 times a root 2 over 2. Okay, so let's plot these points. So angle 0, go out 3. Be right there. Angle pi over 4, go out 3 times root 2 over 2. So it's smaller, so it's something like this. Angle pi over 2, go at a distance of 0, so it's right here. So whenever the r is 0, that's when you're at the origin. When the r is 0, you're at the origin. And so then, let me do one more point here. So what if I did 3 pi over 4? So at 3 pi over 4, I would get 3 times negative root 2 over 2. So the angle 3 pi over 4, which would be over here, go the opposite direction, so I'd be down here. And then angle pi gives me negative 3. So angle pi is over here, and go a distance of negative 3, which means you go all the way over here. So this is the circle that results. So 0 to pi to go all the way around, and the cosine graphs are going to be symmetric with respect to the x-axis. That's just a fact. Okay, so if I was to draw, let's just do 2 times sine of theta. So sine of theta is going to be symmetric with the y-axis. Just a fact. So if I plug in some points, so if I plug in thetas to get different r values, so I'm going to do the same thing. I'm going to start with 0, so that gives me 0. Again, when r equals 0, that's when the point is at the origin. This angle 0, go out 0. There it is. So let's go pi over 4. So I'd get 2 times root 2 over 2. So that, 2 over 2. Okay, so then angle pi over 4, go out to here. Angle pi over 2, I get sine of pi over 2, which is 1, so I get 2. So I'm up here. And then angle 3 pi over 4, I'd get 2 times root 2 over 2, so that would be here. And then angle pi, I'd be back at 0 again. So this is the circle. So this is the circle that just takes 0 to pi to go around. So if it's r equal a, that's just going to be a circle. R is always the distance a, right? This is r. R is always the distance a, no matter what angle. So it's a circle centered at the origin.